Alright everybody, hi, I wish I could be with you today, but I'm watching my daughter compete up in Lexington and hopefully she does really well. But I will miss you and then hopefully everything goes as smooth as silk today, so that's the goal. So your sub has been left everything he or she needs to take care of you guys today. So any handouts, supplies, materials, anything that you may need, they have, everything's labeled and you guys are ready to go. Excuse me. So by now you should have gone over homework. Attendance should be sent to the office. I do ask a favor to you guys though. If you could have one or two people make sure that the fish are fed, just one or two people. Make sure that the fish are fed, please, before you leave today. And then I'll have the other blocks take care of everybody else. So if you guys could. Beta fish literally gets like 4 or 5 flakes. That's it. And the fish in the back tank just gets like a medium pinch of food. So just kind of heads up to that. I would super appreciate it. So at this time, homework should be checked and you guys should be ready to go. What I would like you to do is go ahead and take out your warm-ups. If you cannot locate your warm-ups, which I hope you can, but if you can't, please make sure that you go up to the sub and ask for a new warm-up. I did leave copies for you, so if you don't have it, please make sure you have your warm-ups. Please make sure your name is on it and block. And what I would like you to do at this time is take that out, and you're going to work on day 4. And go ahead and pause this, and then when you're finished and you have it turned in, you can go ahead and hit play. You're going to find that today is going to be really your pace as long as you can get everything done. And at the end, if you have some time, I do have a project that you guys can continue to work on. Okay, so right now go ahead and pause it. Go ahead and take your warm-ups out. We're going to name and block on them, and go ahead and finish day 4 and turn them in when you're finished. And when you're finished, go ahead and hit play again. Alright everybody, so warm-up should be turned in. We're going to kind of do something a little bit different today. You're going to find that there are indicators out there or solutions out there that will tell you how much carbon dioxide and oxygen are in different substances. Now remember, when we talked about cellular respiration and photosynthesis, they are opposite systems. You can't have one without the other. Sorry, everybody. So that means really this. If a group of animals are affected, then plants are also going to have an impact on what's happening there. So here's an example. I have just a typical beaker of water. I'm going to put in something called bromethyl blue into here. And what this is it is I know it turned green right away, right? It is an indicator for carbon dioxide. So if I put some in the water, it's going to turn like a greeny color. Okay, there we go. Okay, I hope everybody can see that it's green. I'm going to put a piece of paper underneath it, so, well, hopefully I can find a piece of paper. So that way you can see that it is absolutely green. There we go. Okay, I turn the light on too. Okay, so what this does is it is green or a bluey kind of color, I guess, until there is presence of carbon dioxide. And then when there's a presence of carbon dioxide into here, it will turn yellow. Okay, so I'm going to go ahead and take the straw and I'm just going to blow out, meaning I'm going to add carbon dioxide to this beaker and let's see what happens. So it might take a few moments. I'm going to try to zoom in as closely as I can and have you guys see at the same time. So here we go. And I hope you can see that it changed from a bluey green to a yellow color. Okay, and again, it is an indicator that says that that is more charged with carbon dioxide than it was before. Okay, and that's going to be important because the simulation that you're going to go visit in a few minutes has to do with looking at how snails and plants interact with each other, and how oxygen and carbon dioxide and sunlight and all of that other stuff fit together with this. Okay, so I wanted you to kind of take a look at this because it's going to refer back to this and you guys can kind of see what happened. Again, it started with like a greeny blue kind of color, and then as carbon dioxide was mixed into there, turned into like a limey yellow color. Okay, so let me put this away real quick. Now, go ahead and raise your hand. What you're going to need is your lab sheet called Gizmo and Gizmo Plants and Snails. So go ahead and raise your hand. You're going to need a sheet that is called Gizmos, Plants, and Snails. Okay, it should look like that. Okay, and I'm going to go through the big top part of it, and then allow you guys, I'll show you where the link is and how to access the simulation, and then you guys will be able to go on your own and kind of explore how carbon dioxide and oxygen and how photosynthesis and cellular respiration really work together. Okay, so go ahead and pause this until you have a sheet, and then you can go ahead and click play. Alright, so at this time you should have a sheet. I'm going to go ahead and read the introduction. We're going to get you started, and then I will show you what this website looks like and how to access it. Okay? Introduction. In this gizmo, you'll see how plants and animals maintain a balance of gases in Earth's atmosphere. You will do this by creating and monitoring a closed system with snails and aquatic plants. Okay? To indicate the presence of carbon dioxide, bromomethyl blue indicator will be used, and that's exactly the stuff that I just put a straw in there. This liquid turns yellow when the concentration of carbon dioxide increases, and blue when the concentration of carbon dioxide decreases. Because plants convert carbon dioxide to oxygen, you can infer that low carbon dioxide levels correspond to high oxygen levels. Okay, so let's go ahead and set this up real quick. I'm going to go ahead and squish this down. I'm going to go ahead and start you off. Circle the correct answers below. Bromomethyl blue turns yellow when, and we just saw that, there are high levels of carbon dioxide and low levels of oxygen. Okay, you just saw that. I blew in and it turned green or bluey green to yellow because I added carbon dioxide into there. The next one, bromomethyl blue will turn blue when there's high levels of oxygen and low levels of carbon dioxide. Okay, so in this case, it is going to be yellow. And in this case, it's going to be blue. So you're going to be able to monitor your snails and your plants to see how balanced your system is that you're going to create. Okay? Everybody good? Alright. So you guys are going to go back to Weebly in just a moment, and you're going to click on the snails and, hang on, let me get that for you. Your snails and plant lab. Okay, when you do that, you're going to notice that it's going to look something like this. Let me just double check and make sure you guys can see this. Alright, cool. It's going to look like this. Okay, you're going to go ahead and you're going to go to login. There should be a login. I'm already logged in, but there should be a login right here. At this time, you and the partner, the person that you're sitting next to, are going to work on this together. So after you get started, you can take your earbuds off for a few moments and complete your lab, but not yet. Now, ask the sub to get you your password and your login. there are passwords and logins that I prepared for each one of you and your partner. Okay? So it's partner, it's a capital letter, and 3 numbers that are right behind there. Okay? And then there's your passwords right here. So I'm going to go ahead and raise your hand, you and your partner. And if you need, just pause for a minute while you wait for your partner. Go ahead and pause. Okay, and then pick up your login and your password from the sub and click on back on Weebly, click on the Plant and Snail Lab link, and it will take you to a website that looks just like this. Okay, when you're logged in, this is what you're going to see. Okay, we're not doing cell structures, but you are going to do the Plants and Snails Lab. So you're going to come over here when you and your partner are ready, and you're going to launch Gizmo. And that's going to take you to a screen that looks very similar to this. At this time, what I need you to do is follow your lab. Your next one says procedure. Drag the snail and a sprig of the plant and put it in test tube A. Now notice that those are all green, right? I'm going to drag a snail, and I'm going to drag a sprig of the plant. And then it says drag a snail to test tube B. And then drag a part of the plant to test tube C. And I'm going to put nothing in test tube D. Gosh, there's a word for that, right? It's called a control. Make certain that the light switch is on. You do have a light switch up here to turn things off and on. And you're going to be able to kind of take a look at this stuff in a little tiny bit, I promise. Okay? And then take a guess. What do you think is going to happen? Are these going to stay that bluey green? Are they going to turn to yellow? What do you think is going to happen? What gas is produced by the snail? Because that gas is produced by that snail breathing out, what color is this liquid going to turn? So I'm not going to give this away, but what I do want you to do is literally follow through the simulation. How you do a simulation is after you're done, you're going to be able to click the play. I'm not going to do it all. And you're going to be able to see the results. So follow through the lab, follow through the simulation. Okay. If you turn to the second page, you're going to have to graph everything. Okay, then you're going to do it in the dark. How is that going to make things different? And then you're going to go ahead and graph all of your results. Answer the questions through 14. And then there's a couple questions at the bottom. When you are done, okay, there should be, if I go to presentation mode, there we go. There should be, I think, I'm not sure where it is. Sorry, guys. Oh, there's some questions over here at the end that I want you to go ahead and answer. Okay, I'm not collecting these, but it's a way for you to kind of check to make sure you're understanding what your lab was doing. Okay, if you want to go in presentation mode, that's fine to do all of your other stuff, and then you click on the 2 arrows up at the top and it'll shrink it back down for your assessment questions. Okay, so when you're ready to go and you and your partner know what you're doing, you can go ahead and pause this, and I'll catch back up with you in a minute. Pause the video. You guys are going to go ahead and work on your lab, answer all the questions, and then when you're finished, name on it. It's getting turned in. I'll grade it for you guys when I get back, and then you can hit play for the next portion. Okay, so again, you're going to go ahead and answer the lab, go through the simulation, answer the questions, and then after that, you can go ahead and hit play again for the next section. In the next section, you're going to be doing independently. So this is the only partner work that you're going to be doing today. Okay, so when you're done, you can go ahead and log off. When you're done, go ahead and log out, and then you guys can go ahead and hit play again. Okay, all right, so have fun with your simulation, and I'll be back with you guys in just a few moments. Alright, so at this time your gizmo plants and snails should be turned in and ready to go. Okay? What I do need you to do at this time is go ahead and ask the sub for a small baggie. Go ahead and ask the sub for a small baggie, please. Okay? In that small baggie, there are 14 cards. There are 14 cards, and I want you to go ahead and take those 14 little cards out and kind of spread them around. Now, please, 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 I'm going to back this up a little bit. Please make sure that all 14 cards get back into the baggie, okay? So that way the next person has everything that he or she may need. So I'm going to go ahead and spread these all out. There we go. And I have oxygen and products and reactants and glucose, good old glucose. Alright, so after doing your lab today and after what we talked about the other day with cellular respiration, what I would like you to do is go ahead and build me what the formula is or what the equation would look like for photosynthesis. So take a moment and I want you to go ahead and build what the equation is for photosynthesis. So we're just going to do photosynthesis first. So I'm looking for photosynthesis. Go ahead and build what that equation would be. And you can go ahead and pause it. I'm going to go over the answer in just a minute. But go ahead and build it and then we'll go through it. Okay? So go ahead and pause, build it, and then push play to check your answer. Alright everybody, so let's go through this and make sure that you're good to go. Okay? So if I have all of these things first, first of all, I'm going to have my reactants. My reactants is what goes in and products is what comes out. So I'm going to make sure that I have reactants and products. And in between reactants and products is kind of like an equal sign. Okay, it means that these are reacted, and because those reacted, this is what it's going to produce to me. And because we're doing photosynthesis first, let's go ahead and figure this out. First of all, with photosynthesis, we're always going to have sunlight. Okay, can anybody tell me what else is going to go into photosynthesis? Okay, carbon dioxide is going to go into photosynthesis. Anything else? And water. Good. All of those things are going to go into and react together. Now, what comes out? What comes out of that? We're going to have glucose and oxygen. Good. I hope you guys can see all that. There we go. Alright, so let's put these chemicals in what the atoms would look like, or the molecules would look like. So glucose is our sugar, which is C6H12O6. Our oxygen is going to be 6O2, which is just literally 6 molecules of oxygen. Water and carbon dioxide. Okay? So let's change that now. I'm going to mix everything up, so go ahead and mix everything up. And let's mix everything up and sit there and say, okay, that's all great. Let's talk about cellular respiration. Now remember, cellular respiration is the opposite cycle. So again, for cellular respiration, go ahead and pause the video and go ahead and build cellular respiration. And then hit play when you're ready to check your answers. Cool. Let's check. Again, we're going to have reactants, and we're going to have products, and we're going to have our arrow to show that this is going to affect this. And let's lay all this stuff out so we can kind of see what we're doing. We take in oxygen, We sure do. We also take in glucose in our food. Those things are going to react together, hence the reactants, and they're going to produce carbon dioxide in what we breathe out, energy that is created, and a little bit of water from the breath that we breathe out. Okay, and let's go ahead and put all of our molecules together. Oxygen is going to be 6O2. Our glucose is going to be C6H12O6. Carbon dioxide, 6CO2. Our energy is going to be our ATP. And water is going to be 6H2O. Okay? So remember, these are opposite systems. If plants and animals, if one of them gets interrupted, they're definitely going to have effects on each other. All right. Now, you should have 14 little pieces here. So go ahead and make sure that you have 14 little pieces. Go ahead and put them back in the baggie, and then go ahead and take them back up to the sub. And then when you're ready to go, hit play again. So I'm going to count my 14, put them in a baggie, take it up to the sub. When you get up to the sub, please ask him for your scenario page, and he'll give you your scenario page, and then we'll go forward. So all 14 in a baggie, take it back up to your sub, ask the sub for the scenario sheet, and then we'll get started with the last part of today. All right, everybody. So you should have all of your cards all put away, and if you have not had a chance to get your scenario sheet from your sub, please pause real quick again and go ahead and pick that up. And we're going to go over a couple of scenarios, just because on you guys' unit test, this was the weakest part. So I want to make sure that we are completely phenomenal at this. Okay? And let's go ahead and read through the first scenario. We have a giant Tyrannosaurus Rex coming through the screen. All right. Anyway, let's move on. All right. So let's read through this and figure out what in the world, how this all works. Okay. So actually, planaria, which is this little worm thing, I'll draw it over here because they're actually kind of cute. You guys will be able to see a planaria in the springtime when we talk about different kinds of worms. Kind of looks like this. It does have eye spots. Kind of looks like this. They're pretty cute little guys. The cool thing about planaria is if you were to cut it in half, this side would grow another right side, and the right side would grow another left side, and you would actually have two planaria. So it's called regeneration. So one side of their body will actually grow with the other side, which would be kind of cool. Yeah, that would actually be kind of cool. So you guys will be able to see these little guys in the springtime. They're pretty fascinating to watch. So Jackie read that aloe vera, and if you've never used aloe vera, it comes from a plant. It's like a gel. It's really good for your skin, especially if you burn yourself. Jackie read that aloe vera helped burned tissue heal faster. She decided to investigate the effect of varying concentrations of aloe vera on the regeneration of planaria. So that means that she took this little planaria little guy and cut it in half. And she wanted to see if she took different amounts of aloe, if it would help it grow back the other side. Okay? All right, here we go. She cut the worms in half to obtain 5 heads. So instead of cutting it this way, you can cut them several different ways, actually, and they will regenerate themselves. She basically cut it in half this way. Okay, meaning that the head would grow another tail, and the tail would actually grow another head. Kind of cool. Group A received no aloe vera. Oh, that's a big hint. Group B received 5% aloe. Group C received 10% aloe vera. Group D received 15% aloe vera. For each group, Jackie used 15 ml of aloe vera solution. All planaria were maintained in a growth chamber with identical food, temperature, and humidity. On day 15, Jackie observed the amount of regeneration of the planaria parts. Okay, so let's start filling this out. IV was, what did she change on purpose? Controls, DV constants. So go ahead and pause, fill it out. Now for those of you who are just going to fill it out as I go over it, it's not really doing anything for you. So please pause, fill it out, and then we'll go over it and make sure everybody's okay. Alright, now that you're done, your IV is going to be, let's see, is it percentage? Yes. Percent of aloe vera. My DV then, what's going to happen because I changed the percentage of aloe vera is the amount of regeneration. Okay. So now that I have that, I can go back up and fill it into my title. The effect of, remember IV always comes first, percent of aloe vera on amount of regeneration. Okay? Hypothesis, I can pick one. So there was 5%, 10%, and 15% used. I believe there's, 5, 10, 15. I'm going to say if 15% aloe vera is used, then, there's my magic word, then amount of regeneration will increase. Okay? So let's talk about our controls. What stayed the same? Controls stayed the same. They had identical food, temperature, humidity. Okay, and they were left in there for 15 days. Levels of IV, there was 0%, there was 5%, 10%, and 15%. And I kind of messed up this, so those are my constants. My control would have been 0% aloe. Sorry, guys, I can't go back or I'd have to do it all over again. Okay, so just kind of shows that you can really mess this up if you don't really concentrate on what's going on. Alright, you guys, so let's go ahead and read the next one. So here's the other thing. If let's say I had 20 planaria, and out of my 20 planaria, I have 4 levels of IV, which are these, 0, 5, 10, and 15. How many repeated trials would I have? So if I have 20 planaria, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and I have 4 levels, that means I'm going to have 5 planaria in each group. So I would have 5 repeated trials. Okay? And if you get stuck on repeated trials, it really helps to draw it out. It only takes a second. Alright, let's take a look at the next one. Chemical X in tomato plants. Mary investigated the effect of different concentrations of chemical X on the growth of tomato plants. Mary hypothesized that if the higher concentration of chemical X were applied, then the height of the plants would be shorter. Okay, that's interesting. She bought 4 trays of tomato plants. Whoa, hold on. 4 trays of tomato plants. Each tray had 10 plants. That's going to be important. She applied chemical X as follows. Tray A got 0, B got 10, C got 20, and chemical and D got 30. Okay. Plants receive the same amount of sunlight and water each day. At the end of 30 days, Mary recorded the height of the plants in centimeters. Okay, so again, go ahead and pause, fill it in, and then push play when you're ready. Okay, so at this time you should be ready. What did they change on purpose? They changed the concentration of chemical X. Okay, and what was going to happen because of that? Height of the plant. I'm going to go ahead and put it up in a title. The effect of concentration of chemical X on height of plant. Okay, now if you have to go back and change things, if I'm going too fast, just again go ahead and pause it and catch up. If now here's my levels of IV. I had 0% is tray A, 10% is B, 20% C, and D got 30%. Okay. Control is going to be 0%. Things that stay the same, sunlight. You're going to find it's right in here. You just got to read it. Sunlight and water each day. Okay, and my hypothesis, I'm going to say if 30% concentration of chemical X is used, then the plant will be the shortest. Okay, now again, let's go back. It's not on here, but let's talk about repeated trials. Let's talk about repeated trials because this is important. There were 4 trays, and in each one of those trays, how many plants were there? You got it. There were 10 plants. Okay, 10 plants had 0, 10 plants had 10%, 10 plants had 20%, and 10 plants had 30%. So my repeated trials are going to be 10 plants. Okay, go ahead and flip it over. And just, I don't want you guys to worry about doing this part of it, but just remember that IV goes on the bottom and DV goes on the side. IV is on your X, DV is on your Y. Okay? Now, I just want to make sure that everybody's kind of caught up and that you guys have enough time to get everything done today. So you have a couple things. You're more than welcome to go back to Gizmo and do the cell simulation. You're more than welcome to do that. Okay. However, the last 15 minutes of class today, I want you to do some research on our garden project. And I want you to do this individually. I want you to be able to go and do some research on school ground gardens and really kind of see what kind of things are out there. What are your thoughts? What are your ideas? This project is not going to be a quick project. It is going to take some time to make sure that everything gets done. But at the same time, you got to get some ideas on what's going on. There's so much that there is. We've just started to deal with birds. We have nothing out there for insects. We have some planters. Let's see. We're not using any recycled materials. We have no way of educating people who are walking by to let them know what's going on. There's so many different things that you can really kind of explore. So use the last 10 or 15 minutes to kind of really get a good idea. Write those ideas down over the next couple days. We'll be able to get in your color group and you can kind of share out what you found. And you and your color groups can really pick on where you want to take it and really start developing it. Okay? There is no homework tonight, so enjoy the night off. However, there is a Quizalize on Unit 3 that you should be able to do and start work on. Okay, there's only 15 questions. Some of that stuff we haven't dealt with yet, but you should be able to get a pretty good idea for what's going on. Okay, so again, I'm sorry I'm not here today. What should you have turned in? You should have your snails and plants lab turned in. And let's see. And I think that's, oh, and your warm-ups. So those are two things that are going to get graded. And then make sure that you have all of your little cards turned in. And I wanted just to go over this as a practice with you guys. Okay. All right, you guys, have fun doing any research. Again, you can go back to Gizmo. You can grab another card from the sub if you want to go do the cell simulation. It doesn't have to be the same card. It could be any of the cards. Okay. All right, you guys, have a great one, and I will see you when I get back. Bye.